We are looking at trigonometric ratios today, right? Which is the ratio of the lengths of two sides of a right triangle. So remember, a ratio is also a fraction, right? And so we're making a fraction or a quotient out of two sides of a right triangle. It's got to be a right triangle for these trigonometric ratios. And we've got three basic trigonometric ratios. We've got sine, cosine, and tangent. Now, for all of you that identify as a junior that will be taking the ACT next week, you might want to pay close attention to this because you will see these things on the ACT, and it at least get you a couple that you might know how to do if you pay attention and learn how to do these on today's notes and tomorrow's notes fairly decently. All right, so I've got an acronym there. Some old hippie cut another hippie tripping on acid. Slightly inappropriate, just enough hopefully to stick in your brains. All right. So, first letter of each word is there to help you remember our trigonometric ratios. All right, so the first one, S-O-H, some old hippie. The S stands for sine, right? And the O is opposite, H is hypotenuse, because the sine of an angle is going to be the side opposite over the hypotenuse. So O for opposite, H for hypotenuse. S is the sine, right? So sine is the opposite over the hypotenuse. So when we look at a triangle here, we're looking at angle A. That's the angle that we're looking at for the sine of. So straight across from angle A is the side opposite, right? And then we've got two sides that make up angle A or that are adjacent to angle A. But one of those is straight across from the right angle, so that one identifies as the hypotenuse. And the other one that attaches or creates angle A is considered the side adjacent to angle A. All right, so sine is the opposite side, which is the A, over the hypotenuse, which is the C. So you get A over C. Cosine of A is the side adjacent over the hypotenuse. Right, so A over H. So caught another hippie. C for cosine. A is adjacent. H is hypotenuse. So cosine is the adjacent over the hypotenuse. So from angle A, the side adjacent is this side, which would be B, over the hypotenuse, which is the C. So you get B over C. And then for tangent of angle A, it's the side opposite of angle A, which is the A, over the side adjacent, which is the B. So that's the tripping on acid part of the acronym. T for tangent, O for opposite, A for adjacent. So tangent is opposite over adjacent. All right. So, questions there so far, anybody? All right, so here we have two different triangles. Triangle 1, triangle 2. We want to compare the sine, cosine, and tangent ratios for angle A in both triangles above. All right, so if we look at triangle 1 for angle A, we're looking at that angle right there, right? So for angle A, which side would be opposite of angle A? So we've got the side opposite is BC, right, it's going straight across from it. And then which side is the hypotenuse? BA is the hypotenuse, or the length is 13. And then which side would then be adjacent? CA, right? The only side left that didn't have a label on it. All right, so when we look at the sine of angle A, right? Sine, right? That's the some old hippie, SOH. So sine is the opposite over the hypotenuse. All right, so when we look at it, for triangle 1, angle A, the opposite is 5, and the hypotenuse is 13. So we get the ratio 5 over 13. All right, so then for cosine of angle A, and cosine is the caught another hippie, CAH. So adjacent over the hypotenuse. And so that's going to give us what for the ratio? 12 over 13. And then the tangent. Tangent is the tryptophan acid part of the acronym, TOA. O for opposite over A, the adjacent. So we get 5 over 12. Right. So now for triangle 2. Also still looking at angle A. And the two triangles are in the same orientation, so all the sides that we looked at on the first triangle will match up with the sides in the second one. So BC is going to be the opposite. BA is the hypotenuse. And CA is the adjacent. So for the sine of angle A, opposite over the hypotenuse, it's going to be what? 2.5 over 6.5. How about the cosine of A, which would be the adjacent over the hypotenuse? 6 over 6.5. And then the tangent of A, opposite over adjacent. All right, so when we compare those, if we look at those, may not make much sense when you look at them as fractions, but a lot of times when they ask for the sine, cosine, or tangent, they'll want it in a decimal answer. So if I do 5 divided by 13, that'll give me 0.3846 for 5/13. If I do 2.5 divided by 6.5, then I'm going to get 0.3846. All right, so then 12 over 13 be 0.9231. And it's fairly standard that when you ask for sine, cosine, or tangent, that it's going to want it to 4 decimal places. All right, so 6 over 6.5 is also 0.9231. And then for the tangent, 5 over 12 0.4167, and 2.5 over 6, 0.4167. So when I look at those, I see that I've got two different triangles, but my sine, cosine, and tangent values are all exactly the same. Alright, so we get the same trig ratios for both triangles, which what that means is that these two triangles are similar triangles. Because the ratios are the same, that means that angle A for both of these triangles has to be the same. All right, so whatever the angle A is here, you got the same measure of angle A over here. So the triangles are similar because the sides are not exactly the same, but the angles have to be the same. And so what you find is that every angle, every specific type of measure of angle has a specific sine, cosine, and tangent for it, which allows us to identify an angle from knowing what the sine or cosine is later on. All right. So next up, I'll find the sine, cosine, and tangent for the indicated angle. So we're going to look at the same triangle and two different angles inside the same triangle. So first off, we're looking at angle D. So when we look at angle D there, which side is the hypotenuse? ED is the hypotenuse, which has a measure of 50. All right, which side is the adjacent side? FD is the adjacent, and the opposite side. Yeah. All right. So I'll go ahead and put the trig ratios up here for us. Sine is the some old hippie, right? SOH. So opposite over hypotenuse. Cosine is CAH, caught another hippie. So adjacent over hypotenuse. And tangent is the tryptophan acid. So OA, opposite over adjacent. So for angle D, the sine of D is going to be the opposite side over the hypotenuse, which is going to give us what? Opposite over hypotenuse. 14 over 50, which you could reduce the fraction to 7/25, which would be 0.28 if we write it as a decimal. The cosine of D, the adjacent over the hypotenuse, which is 48 over 50, which would reduce to 24/25, or 0.96. And the tangent is 14 over 48, opposite over adjacent, which would reduce to 7/24, or would be 0.2917. All right, so that's for angle D. Next one is for angle E. So for angle E, basically the opposite and adjacent sides switch places. The hypotenuse isn't going to change, right? Because the hypotenuse is always whatever is straight across from the right angle. So our hypotenuse stays the same, but our opposite and adjacent switch. So that's going to be adjacent. That's going to be opposite for angle E. And so the sine of E is going to be what? 48 over 50. Or 24/25, which is 0.96. Then the cosine of E, the adjacent over the hypotenuse, so 14 over 50, or 7/25, which is 0.28. And the tangent of E is going to be the opposite over adjacent, 48 over 14, or 24/7, which will come out to be 3.4286. So one thing to recognize, or a couple things to recognize here, right? When we look at two angles in the same triangle, the sine of one of the angles is the same as the cosine for the other angle, right? And now tangent, you just flip the ratio, right? Or you got the reciprocal of the ratio. And another thing to recognize is that tangent is the only ratio that can be a number greater than 1, right? So sine and cosine, that's always one of the sides of the triangle over the hypotenuse, and we should know the hypotenuse is always the longest side, right? So whether it's this side or this side over the hypotenuse, it doesn't matter because they're always going to be smaller than the hypotenuse. So you've got a smaller number over a larger number, which gives us a decimal value between 0 and 1. But for tangent, you have the possibility to have a bigger number over a smaller number, which gives us a ratio that's going to be bigger than 1 possibly. So if you have a number bigger than 1 for your sine or cosine, you know you've messed up, right? You can't have a bigger number than 1 on tangent. And another thing, just to state it right now, because it's an annoyance for me as we go on and do this. When you see SIND, do not read that as sin D. Read it as sine of D. Right? COSD, don't look at that and say cos D. That's cosine of D. They're abbreviations for words that have a full word meaning. And TAN of D is not tan of D, it's the tangent of D. So sine, cosine, tangent. These are just the abbreviations of those. All right. So next up, we want to find the value of each trigonometric ratio to the nearest 10,000th. All right, so 10,000ths is how many decimal places? And if we have a decimal place, the first one is the tenths. Hundredths is the next one. Thousandths is the third one. And 10,000ths would be the fourth one, right? So four decimal places we're looking at if it says for the nearest 10,000. All right. So the sine of 47 degrees, we've got no triangle here, right? We just got an angle measure, which means we're going to use our calculator. And now, whenever we use a calculator and do any trig ratio stuff, sine, cosine, and tangent, you have to make sure that your calculator is in the right mode, because every calculator has more than one mode that you can figure trig ratios in. And so on a graphing calculator, we hit the mode button and it'll take us to this screen, and this line right here where it says radian or degree, that's what's important when we're doing trig ratios, right? And what we're dealing with angles that have a degree measure, right? 47 degrees, 82 degrees, 53 degrees. So we've got to make sure that the degree is highlighted. If you've got just a basic scientific calculator, then on that window where the number comes up, there should be, in most cases, a little DEG or a little RAD that you would see in that window somewhere. If you see RAD, that means that your calculator's in radians and needs to be changed. If you've got DEG, then you're in degrees and you're good to go. All right. So, as far as radians go, you don't have to worry about those until you get into a trig class, because radians are based on a circle being a total of 2 pi, and so then radians are portions of 2 pi that will give you parts of a circle. So don't have to worry about that, just make sure that you got it in degrees, otherwise your answers will be wrong. Okay. All right, so now we know that our calculator is in degrees. Then finding the sine of a 47-degree angle is as simple as hitting the sine button and 47. So the sine of 47, we hit enter, we get 0.7314, because look to the right of the 3 and that's a 5, so we round up. So 0.7314. So the next one, cosine of 82. So the cosine button, 82 degrees. If you're in a scientific calculator, sometimes you have to put the degree measure and then hit the cosine or sine button. So cosine of 82, hit enter, and 0.13917. So look to the right of the 1, it's a 7, so we're going to round up. 0.1392. And then lastly, tangent of a 53-degree angle, tangent button, 53, and enter. So 1.3270, and to the right of the 0 is a 4, so it stays a 0. So 1.3270. So if you got the angle measure, finding the sine, cosine, or tangent of that angle measure is pretty simple. Just plug it into the calculator and get your value off the calculator. All right, so then one last triangle here. I'm going to find the sine, cosine, and tangent of angle A. So we got an angle at A there. Can anybody tell me what kind of triangle this is? Just looking at it. It is a right triangle. And it's an isosceles right triangle because we've got two sides that are 18, right? And what else does that tell us about that triangle if it's an isosceles right triangle? Something we learned about right triangles before the break. Anybody can remember a week and a half ago. So what do we know about the angles if it's an isosceles right triangle? Well, we know if it's got two congruent sides, then it's got two congruent angles, right? So angle B and angle A should be the same measure, which would make them have to be what? If it's a right triangle, right angle makes 90 degrees, which leaves 90 degrees for the other two angles. And half of 90 is? So that is a 45, 45, 90 special right triangle. Which actually fits what we learned about special right triangles, because we learned that, or on a 45, 45, 90, the two legs are the same, right? We put those down as x's, and the hypotenuse was the square root of 2 times the leg, right? Which you got 18, 18, two sides are the same. The hypotenuse is 18 square root of 2, which is the same as the square root of 2 times the leg, right? So when we figure this sine, cosine, and tangent, we know that we're finding the sine, cosine, and tangent of a 45-degree angle. So what we find here will be true for any 45-degree angle. So when we look at the sine of angle A, so which side is the opposite side? All right, so BC is the opposite. Can't just say 18 because we got two 18s, right? All right, what's the adjacent? C to A. And that would make the hypotenuse B to A. So for sine, we're looking at the opposite over the hypotenuse, which is going to give us 18 over 18 square root of 2. Can we leave it like that? Now we got a radical in the denominator. We can't leave a radical in the denominator. Of course, right now we can see that we've got 18 over 18, so those are going to cancel each other out and just become 1s, right? And then the square root of 2, and multiply the top and bottom by the square root of 2, which is going to give us the square root of 2 over 2. Cosine of A. Cosine is the adjacent over the hypotenuse, which the adjacent side is CA, which is 18 over hypotenuse, which is 18 square roots of 2. So same exact thing as we got for sine, which should make sense because it's an isosceles triangle. So 18 over 18 square roots of 2, which we know ultimately is the square root of 2 over 2. And the tangent of A going to be the opposite over the adjacent, or 18 over 18 is 1. Right? So anytime we have an isosceles right triangle, these are the values we should get for sine, cosine, and tangent. Square root 2 over 2, square root 2 over 2, and 1. All right, questions? Anybody?